Hello and welcome to the course Machinery Fault Diagnosis and Signal Processing. Today's topic of discussion is motorcycle handlebar vibration problem. Now this is an MTech project for the batch 2018-19 and the title was Design of Motorcycle Handlebar for Reduction of Vibrations Using Tune Mass Damper. And the student was Sumit Khune. Now, in case of motorcycles, vibrations are transferred to the human body from 3 points. First is the foot pegs, second is handlebar, and third one is seat. So these are the 3 points from where the motorcycle vibrations are entered into the body. Now the motorcycle vibrations may be because of the engine vibrations or because of the road irregularities. So all these road irregularity vibrations or engine vibrations are transferred to the human body from the 3 parts, that is foot peg, seat and handlebar. In today's presentation we are dealing with handlebar vibrations. We try to arrest, try to attenuate, try to mitigate the handlebar vibrations so that it will not enter into the human body. And the long exposure of vibrations to rider may lead to several body disorders such as disorders in the ligaments, bones, joints. Sometimes it may affect the nervous system also. So the long exposure to these vibrations are not recommended from the medical field, and long exposure to such vibrations may lead to disorders in ligaments, bones, joints, etc. Occurrences of such disorders are categorized under whole body syndrome or hand-arm vibration syndrome. So there are 2 types of syndromes which are categorized by the medical fraternity, that is whole body vibration syndrome and hand-arm vibration syndrome. Number of international organizations have provided standards and guidelines for the measurements and evaluation of vehicle vibrations such as ISO 2631 and British Standard 6841. So ISO 2631 and BS 6841 deals with the whole body vibrations standards and guidelines. As far as hand-arm vibrations are concerned, the standards are ISO 5349-1 and ISO 5349-2. So these are the 2 ISO standards which provides the guidelines for hand transmitted vibrations to the human body. Now the focus of the present work is, the present study is carried out to investigate the vibrations in the handlebar of a motorcycle and incorporate a modification to reduce the vibrations for good ride comfort without affecting its handling. The handlebar is modified by using tune mass damper to attenuate vibration amplitudes. So we are using a tune mass damper. Okay. We are converting a single degree of freedom system to 2 degree of freedom system by incorporating a tune mass, and by using this principle or by using this phenomena, we are trying to reduce the hand-arm vibrations or handlebar vibrations so that it will not transfer to the human body, and particularly the riders which rides the vehicle for long hours, or the riders which are exposed to handlebar vibrations for long period of time, these modifications are very important to such applications. Now the experimental setup, we have taken a Royal Enfield vehicle because most of the riders they are using the Royal Enfield vehicles. So we have carried out the experimentation on the stock handlebar and the modified handlebar, and then compared the vibration levels at the stock handlebar and the vibration handlebar. Now attune mass damper, here we have uh, used uh, bar ends or the hollow bar ends of 135 gram each, and we have inserted these bar ends at the from both the sides of the handlebar. Now handlebar mountings, we have maintained different mountings for the handlebar for the experimentation. First is plain handlebar, then second one is bar ends attached to handlebar, that is handlebar plus bar ends, then lever mirror switches mounted on the handlebar, so it is uh, HB plus LSM lever switches and mirrors, and then bar ends and other accessories installed on the handlebar, that is HB plus BE plus LSM. So these are the four different um, mountings on which we have carried out the experimentation, one for the stock and one for the modified one. So these are the vibration amplitudes for the stock handlebar. The blue line indicates the plain handlebar, the orange line indicates the vibration levels of handlebar plus bar ends, then the grey line indicates the handlebar plus uh, uh, that is mirrors switches uh, and bar end plus mirror switches plus bar ends and handlebar, so it is represented by blue. So basically we are using a different mountings on the handlebar, and this is how the vibration amplitudes are varying. Now here you can see that for at 60 hertz frequency, the vibration amplitude is as high as 170 meter per second square, which is very high uh, amplitude. Now these are the vibration levels for the modified handlebar. Here also four different mountings are provided, and here you can see that the maximum vibration level is around 130 meter per second square for 60 hertz frequency. So from these graphs we can clearly see that the vibrations levels have reduced considerably in the modified handlebar than that of the stock handlebars. The study presents the successful implementation of tuned mass damper for attenuation of handlebar vibrations. Best results are obtained in case of bar ends plus uh, lever switch and mirror in both stock and modified handlebar. It is inferred that the location of the addition weight plays crucial role in vibrational behavior of the handlebar. Okay. So it is not only the mass, but the distribution of the mass is also very important for attenuation of vibration handlebar. Addition of weight at the end of the handlebar would result in increase of handlebar vibration. It is observed that weight should be uniformly distributed over the span of the handlebar for the attenuation of handlebar vibrations. Most of the people, they use bar ends to reduce the handlebar vibration, but in this study we have observed that merely adding a weight at the bar ends at the end of the handlebar would actually increase the vibrations, and it is not recommended that you put the bar ends to the handlebar. Always distribute the mass to the span of the handlebar so that it is uniformly distributed, and the uniformly distributed weight has shown the results that it is more effective in vibration attenuation. From the study, it is also observed that the effect of tuned mass damper is substantially visible at the higher engine RPMs. So as compared to lower RPMs, the results are better at the higher RPMs. So those riders who are constantly exposed to these vibrations at higher speeds and for long period of time, for such riders, this type of modification becomes extremely important and essential. Okay. So this is the conclusion from this study. So thank you.